All right, let's try a quick experiment here. The question is, objects of different weight, if I drop them about the same time, will they hit about the same time? Now, having seen enough of that preliminary test that you've taken, even though I'm recording this before you've taken it, odds are a good chunk of you believe that the heavier object hits first. Well, let's just do a quick test to see if that's true. I have a book, I have your textbook, and I have an Expo marker. These do not weigh the same thing. Now you can try this at home and see if you get the same results. But I'm going to start them about at the same level here, showing off my coordination. I'm going to drop them and just see how they've fallen. Now that was very quick. So if you do start doing pause frame as you hit play, pause, or maybe you can do single frame advanced, you can see that they're still falling about the same rate. Now a couple questions here. One, why does that happen? Why do heavier objects fall the same rate as lighter objects? What about air resistance? And the other one is, why do some people believe the heavier object? I've done this demonstration in front of a class before. Then gave the assessment that you guys took the first day, and I still had a student say the heavier object is going to hit first, despite the fact that we had done it 10 minutes before she took that quiz. There's, again, going back to one of the other videos I'd done, there's something comforting in this idea that the heavier object hits first, but it doesn't. No. The question is why? Well, first question, let's deal with the wind resistance. Air resistance is a factor, and air resistance is incredibly complex. We're going to ignore it for the most part. There's a section where you need to know what terminal velocity is, but air resistance is not something that we really spend much time with because the math is so complex, as well as you quickly get into problems that are not solvable analytically. You need a computer. But when dealing with air resistance really makes a difference the faster an object's going. These objects are not getting fast enough while they're falling so that you don't have to worry about it a whole lot. The other one is, why does it happen? Well, there are a couple explanations. If you think about it one way, the book weighs more. That makes sense. Than the marker. So there's more force acting on this than acting on this. Now, you might still be thinking, more force is acting on it, why doesn't it move faster? Well, it also has more mass. The greater the mass, the more force is required in order to get it to move. If you think about, if I'm trying to push the book or the marker across the table, the marker is a lot easier to move. It doesn't require as much force. Well, when falling, it balances out just right. The amount of force acting on the book, the amount of force acting on the marker are different, but because this has less mass, it doesn't need as much force, and it bounces out to the same acceleration. And ultimately, since they start at the same speed, they fall at the same speed, velocity all the way down. Now, another explanation is, suppose I took two markers, let's pretend that they're identical, two markers, and I dropped them side by side. Most people would expect that they're going to fall at the same rate. Well, suppose I have them side by side. Well, that doesn't change anything. So they should still fall at the same rate. Suppose I had a tiny little piece of glue there, not enough to really change the mass, and I attach them together. Well, that doesn't change whether they're stuck together or whether they're falling like this, they still fall at the same rate. And so no matter how many markers I add, that doesn't change the fact that each individual one is still falling at the same rate. And so thereby, extrapolate that, I have, if I have 10 markers here and I have one marker here, well, there's no reason for each individual one of the 10 to fall any faster. Just because you're holding on to someone doesn't mean that you're going to be moving more. Still, you can treat anything as a collection of individual objects or as a whole. So those are two explanations for why it happens. I hope some of you remember that. I hope all of you remember this. I hope those of you who were thinking the heavier one will hit first, well, I think you would be wrong. And just one quick side note, there was an episode of Andromeda where the two main heroes had just beaten up the bad guys who fell over this very tall bridge. Why you build a tall bridge like that over a chasm, I don't know, without railings. But they fell over, they hit the ground, and while the bad guys were falling down, the good guys were betting who's going to hit first, and one of them hit first, and the comment was, well, your guy was fatter. If you bring an air resistance into it, then the fatter guy actually should have hit second. Ignoring air resistance, they should have hit at the same time. It's unfortunate when bad physics makes it into television entertainment, but it's something that, as physicists, as educated people, what we do is when they do that, you go, if you're wearing glasses, take them off and go, well, that's not exactly right. If you raise the eyebrow, you get a little bit more cachet with your comments. But one thing I hope you do learn in physics is how to get the look. But that's a different lecture.